Hello everyone, welcome to my YouTube channel. So today we're going to continue to look at factors that could affect poor homocysteine. So the next point I'm going to be discussing now would have to be poor chromogen development. Poor chromogen development. Before we continue, my name is Dr. Emmanuel Obodo. I'm a biomedical scientist and I'm also a lecturer in biomedical science here in the United Kingdom. Now, what I try to do whenever I try to talk to you guys is to explain some bit science of what we are dealing with. Okay, now when you say poor, you already know what it means. That means it's not good enough. Now chromogen talks about chromo talks about color. Okay, so the chromogen has to do with the color. Okay, so when we say development, it means that the color development, that means the color that is developed following the antigen antibody binding. Okay, so when we say poor chromogen development, it means that the color has not developed the way it's expected to develop. And once the color does not develop the way it's supposed to develop, that means that the IHC staining has not been properly stained. Does that make sense? So that is what we are going to be looking at. So what exactly could lead to that? So, but the chromogen development is one of the factors that could lead to poor IHC staining. I hope that makes sense. Yeah. Now, I want you to look at the fact that maybe the color development has developed quicker than expected, or maybe it is the development is either insufficient, like lower, or maybe the development is excessive than required. So whichever way, what you want the development is to be moderately developed. Okay, you don't want to be insufficient and you don't want to be excessive. So once you have either excessive or insufficient development of the very chromogen, that means that IHC staining has not been properly stained. I hope that makes sense. Okay, so we are going to look at what exactly could lead to this. Now, remember, we had mentioned something like all kinds of things that we've said in the past could actually lead to the color development. Remember, the color development is actually like towards the end point of the very process. I hope that makes sense. Okay, so now what it means, whether if you get it wrong from any of the factors that we had mentioned in the past, whether it has to do with the inadequate antigen retrieval, whether it has to do with the maybe blocking, whether it has to do with the primary antibody selection, whether it has to do with secondary antibody, whichever way, once there is any of those factors that has not been properly done, directly or indirectly, is going to affect the level of the color development. So once there is poor chromogen development, it could be any of the method as already mentioned. But let's say, for example, any of those methods are still okay. The method can still be okay. Maybe there's no problem with any of the samples or the primary antibody or the secondary antibody or the blocking, or as the case may be. One other factor could be when we don't know when we should be able to stop that very color development. So what it means that we then need to optimize and a kind of monitor development time. So we need to find out at which point do we expect maximum development. What it means is that once we've optimized and validate when we should expect the maximum development time, once it gets to that time, we should be able to stop that very development. So it's important that we monitor that, because sometimes that coloration, the excess color could be due to not the antigen, it could be due to the artifact. Okay, it could be due to some of the non-specific proteins that could also contribute to that very color development. That is why it's important that we carefully monitor the incubation time to be able to prevent this very overdevelopment of the coloration, which could be as a result of what? Artifact. So it's important that we are very sure when this color is going to be developed and make sure that that is well monitored. It's important that where possible we prepare a fresh chromogen solution. That way, as prescribed by the manufacturer, as the case may be, but that way it can be able to ensure optimal activity of that very chromogen solution. So in order to in order for the IHC staining to benefit from optimal activity of the chromogen solution, it's important that sometimes we may need to employ fresh chromogen solution preparation. I hope that makes sense. So I have said that poor chromogen development can lead to poor IHC staining. It's one of the main factors that could lead to poor IHC staining. What do? We need to make sure that we kind of validate or verify or optimize, okay? Monitor the development of the time that is required. Once we know the development of the time that is required, we make sure that we stick with that development time. That way it can avoid the excess, color development, which could be as a result of what? Artifact. And also, where possible, the chromogen solution, we should be able to prepare fresh chromogen solution. That way it can help to ensure optimal activity of that very chromogen. So here you go. This is also another factor that could lead to poor IHC staining. I hope that makes sense. So do let me know what you think about the video. Please, can I ask you to like, share, comment, and I wish you all the best. I come back away again. Bye-bye.